Hello students, previously lesson 19 from 3 to big 2 we were dealing with the direct titration and we were in the first aim, that's determining the unknown concentration of the analyte. We have done question 3 and question 4. So today lesson 20 we are going to do question number 5 of that direct titration with the aim of determining the unknown concentration of the analyte. So the question that we are going to do is the format of the KCSE Chemistry Laboratory Practical, that titration side. Okay, you are told you are provided with sodium hydroxide solution, 0.2 molar hydrochloric acid. So the aim of the practical is you are required to determine the concentration of sodium hydroxide solution in moles per liter, but B, grams per liter. So this is the aim of this practical. So the procedure for this titration question, the first we are told by bait 25.0 centimeter cube of sodium hydroxide solution into a conical flask, add 2 drops of phenolphthalein indicator and titrate with hydrochloric acid, then record your results in the table below. So we have already filled for you the table. Okay, let's see this question number 5, our standard solution and also our analyte. Because you see direct titration, we have 2 solutions. So in our case, sodium hydroxide is the analyte because we don't know its concentration. Hydrochloric acid is the standard solution because we know its concentration. Okay, we check. You have already been filled for the table, titration table, and we have titration 1, titration 2, and titration 3. And you are told when you are doing titration experiment, 3 experiments are done, and they are supposed to be consistent, and they are supposed to have a range of plus or minus 0.2. So if we check the first experiment, the volume of the acid used is 25.0, and the second is 25.0, the third experiment again is 25.0. So that means we can add the 3 to get the average volume of the acid used. So part A of the question, we are told calculate the average volume of the acid used. So if you are told calculate the average volume of the acid used, here we did a 3 titration. So that means if you check the volume of the acid used, it's 25.0, here 25.0, here 25.0. So all of them are in the range of plus or minus 0.2. So all of them can be added and divided by the number of trials or the number of titrations that you have done. So to get the average volume of the acid used, we are going to say 25.0 plus 25.0 plus 25.0, then all divided by 3. This one will give us 25.0. 25.0. But don't forget the unit, it is centimeter cube. You have been given here volume of the acid used in bracket centimeter cube. So learners, when you are putting this in the calculator, first of all you have to add 25.0 plus 25.0 plus 25.0, say equal, then divide by 3. But if you just put 25.0 plus 25.0 plus 25.0 divided by 3, you get wrong answer. So we go part B. We go part B of the question. We are told calculate calculate the number of moles of hydrochloric acid used. Remember, hydrochloric acid was the standard solution because we know it is concentration. We are given 0.2. So what is the formula for calculating number of moles? Number of moles or moles is equal to molarity times volume used over 1000. So in our case, the molarity of hydrochloric acid is 0.2. It is given here, 0.2 molar hydrochloric acid. So we are going to have 0.2 times the volume used of hydrochloric acid is 25. It is here. Calculate the average volume of the acid used. So we have gotten 25.0. 25.0, then divided by 1000, which is in the formula. So this will give us 0.005 moles of hydrochloric acid. That will be the number of moles of hydrochloric acid used. Okay, but Romeo 2, we are told number of moles of the sodium hydroxide used. Sodium hydroxide was the analyte, so we can get the number of moles of sodium hydroxide by writing the chemical equation for the reaction between the standard solution and also the analyte. So we can have sodium hydroxide aqueous reacting with hydrochloric acid aqueous. We are going to get sodium chloride aqueous and also water, which is liquid. So this equation is self-balanced. Let us see now the ratio of sodium hydroxide and also hydrochloric acid. The mole ratio is 1:1. So we know the number of moles of hydrochloric acid, it's 0.005 moles. So if we know this 0.005 moles, what about the number of moles of sodium hydroxide? We can cross multiply. So there we are going to get 1 times 0.005 divided by 1. So this will still be 0.005 moles of sodium hydroxide. That will be the number of moles of the sodium hydroxide used. So part C of the question, we are told calculate the concentration of sodium hydroxide in moles per liter. Concentration in moles per liter, we said, is also known as molarity. So how do you calculate molarity? So molarity is equal to moles times 1000 divided by volume used, or volume of sodium hydroxide, volume used. So to put this one, the number of moles of sodium hydroxide is 0.005 multiplied by 1000 divided by the volume used, or the volume of sodium hydroxide, which we are given in the procedure side. So we are told by bet 25.0 centimeter cube of sodium hydroxide solution into a conical flask. So that means the volume is 25. It is given 25. So here we are going to get 0.2 mole, 0.2 moles per liter, which we can write 0.2 m capital letter. That's the molarity, or the concentration of sodium hydroxide in moles per liter. So, but Romeo 2, we are told concentration of sodium hydroxide in grams per liter. So yesterday, or the previous lesson, we were having the formula for calculating concentration in grams per liter. We said this one can be gotten by molarity times RFM. So if we are dealing with the sodium hydroxide, the concentration of sodium hydroxide in grams per liter, we have to get the RFM of sodium hydroxide, RFM of sodium hydroxide. So the RM of sodium is 23, plus the RM of oxygen is 16, plus 1 for hydrogen will give us 40. So using the formula concentration in gram per liter equal to molarity times RFM, the molarity of sodium hydroxide is 0.2 multiplied by the RFM of sodium hydroxide, which is 40. So here we are going to get 8.0. We are going to get 8.0. And the unit is gram per liter. So we are going to have gram per liter. So that is the concentration of sodium hydroxide in grams per liter. That's the end of our video.